Hello students, we are meeting for the last lecture of the chapter, that is parameters of instrumental analysis. And up till now we have discussed the from the beginning. If I recap all the topics which were discussed under this chapter, first we started with the understanding of some terms like techniques, method, procedure and protocols, then total analysis technique, concentration technique, then selecting analytical method, and under that criteria for choosing analytical method. And there are nine criteria that were discussed: accuracy, precision, sensitivity, selectivity, robustness, scale of operation, analysis time, availability of equipment and cost of analysis. Then at the end making the choice of final choice of the method is also were discussed. Now we'll start with the last point of this chapter, that is developing the procedure. Means once we have selected particular technique, particular method for the analysis, then how to develop the procedure. The selection of the method is followed by developing this procedure that will fulfill the goals of analysis. While developing the procedure, following points need to be considered. Under that, handling interferences, calibration of appropriately selected equipment, standardizing the method, acquiring representative sample, and validating the method. These are the five steps that we have to follow. We'll discuss each step separately Separately in detail. First is handling the interferences. So as were discussed in the earlier lecture, that accuracy of method is very important issue while selection of a particular analytical method. So this accuracy depends on the selectivity of the sample. There are two sources of interference, means two sources of errors. First is either sample may contain any interferent. For example, if you want to analyze any alloy, in that along with the desired or selective analyte, there may be other metals which may present and cause the role of interferent, or sometimes the reagent added might contain the interferent. So in the absence of interferent, the total signal measured during the analysis is the sum of the signal due to analyte as well as plus signal due to the reagent. So this total signal measured is equal to signal due to analyte plus signal due to reagent. So signal due to reagent can be measured by measuring the signal of reagent, which is called as blank measurement. Does not contain any alert. Means, for example, if you are performing in colorimetric analysis, in that you are for getting the desired color of the analyte, you are adding some complexometric reagents. So in when if the reagent is creating some interference, in that case you have to add all the reagents except the analyte. Okay, and you have to measure the absorbance for that, and for that sample, that sample is called as a blank sample, and for that blank sample you can set the reading as 0. Means after that, when the analyte is added in that along with the reagent, whatever absorbance you will get, that will be measured only for the analyte, not for the reagent. So this is one method of handling the interference while performing the analysis. Second is calibration and standardization of equipment. Calibration is the process to ensure that signal measured by instrument or an equipment is correct. So calibration is done by using standard known to produce an exact signal. Means you have to take the solution of known concentration and you have to note down the exact signal. Okay, for example, if you are performing colorimetric estimation, prepare the standard solution of say 1 milligram, 2 milligram, 3 milligram, 4 milligram and 5 milligram. Measure their corresponding absorbances and plot the graph. That will give you the calibration curve like this. Okay, so standardization is the experimental process of establishing the relationship between the analytical signal and the amount of analyte. Okay, so in the case of total analysis method, standardization can be easily defined from the stoichiometry of the reaction. Means when you are adopting any analytical method where total analysis is involved, directly this you can calculate the amount of analyte present using the stoichiometry. But when you are performing the concentration technique, in that relationship between signal and analyte has to be developed, which cannot be developed using stoichiometry, and for that such graph or calibration curve has to be plotted. For example, colorimetric estimation of unknown concentration of KMnO4. So here what you have to do, you have to take the standard solution of KMnO4, prepare of different concentration, measure their absorbances and plot such graph. Then you can measure the absorbance of unknown, and using this calibration curve you can find out the concentration of unknown. So calibration and standardization of equipment is the important step while developing the procedure. Next, very important is sampling. Okay, sampling is very important because see, selection of analytical method for the analysis, you can reduce the error by performing different adopting different methods like measuring the absorbance or signal for the blank solution or like that. But if sampling itself is wrong, then you cannot help, because sampling has to be correct, sampling has to be representative of bulk material. For example, in industry, suppose they want to check the purity of the incoming or the chemicals which they have purchased, so they can take the sample. But if you want to find out the spread of pollutant in the soil, so you have to take a representative sample. If you take a sample where there is no pollutant, or where there is a very highly extreme pollution is there, then that will not help. So you have to take number of samples in that case, and then you have to make the clear picture. So sampling actually create the error, but this has nothing to do with the errors due to analytical method. But sampling has to be representative, then only accuracy or the usefulness of the result will be helpful. Then next is validation. Once a procedure is developed for particular sample analysis, it has to be validated to check whether it gives accurate or precise results. Okay, so the process of verifying whether procedure gives acceptable results is called validation. Means suppose nowadays all of most of the people who are get affected, infected due to coronavirus, they go for RT-PCR test. So this RT-PCR test gives you the score. Okay, so first you have to validate with number of samples, then only you can use it on the real life. Okay, so the validation of the sample is very important. Okay, if that leads to something wrong conclusion, then it is not useful. So to get the correct conclusion from the analysis, you have to validate the process. And the last point is protocol. Protocol, as I told you in the first lecture only, the protocol is a set of stringent written guidelines specifying the exact procedure that must be followed so that results are to be accepted by agency specifying the protocol. Just now I have given the example of corona test, that is RT-PCR test, which gives you score. That test has to follow the protocols given by ICMR. Okay, so in India for medical test, ICMR is the agency that gives these stringent written guidelines. Okay, so when designing a procedure, a protocol also contains very detailed instruction about internal and external quality assurance and quality control. quality control procedures. Internal quality assurance and quality control gives the steps involved to ensure the analytical work in a given laboratory is both accurate and precise. External quality assurance and quality control involves the process in which laboratory is certified by external agency. One such agency is Environmental Protection Agency. So protocols are basically the rules or guidelines which comes from the agency so as to protect the so as to you can say follow the act given by the authority. So protocol has to be followed, especially when there is a question of health issues or pollution issues. You have to follow that government act rules. Okay, so this gives the protocol. Now this completes our chapter parameters of analytical instrument. Now here we'll come to the end of this chapter. Again I am repeating here, if you have any problem you can ask me on Google Classroom. I'm going to post the links of these videos on Google Classroom, so there only you can ask me and I will reply your queries. Okay, so I will stop here. Thank you.